Welcome, ladies and gentlemen, to this video lecture. Okay, so what is our goal? We would like to be able to solve polynomial equations over C. So, or in other words, we want to be able to find the roots of polynomials. So these can, depending on how complicated the polynomial you have that you're looking for the roots of, this can become quite complicated. But there are some strategies that you can try that will help you to compute the roots of some given polynomial. So let's try the first strategy, and the first strategy is guess a simple root. So guessing is a perfectly valid strategy. So if you have some polynomial f of x, a polynomial over C, you can guess that 1 or minus 1 or I or minus I is a root of f, of fx. And what you can then do is you can apply the factor theorem. Let's spell that correctly, factor theorem. So what you do is you just plug in your guess for a root and you check, do I get 0? Because if we get 0, remember by the factor theorem, if we get 0, then x minus 1 in this example is a factor of our polynomial fx. Or, and now we try f of 1. We check, do we get 0? F of I, we check, do we get 0? And f of minus I, we check, do we get 0? Etc, etc. So by guessing just a couple of numbers, it could happen that one of these, if we substitute these numbers into f, that we get 0. And by the factor theorem, if we get 0, then we know that we immediately have a factor of our polynomial. We can apply long division and then repeat the process. So this is our first strategy, is just to guess a root of our polynomial. Second strategy is, if fx is a polynomial over R, and we have a root, a complex root of fx, then we immediately know that that the complex conjugate of C is also a root. Then the complex conjugate of C is also a root. And now again, let me reiterate here, our polynomial must be over R. This does not work if our polynomial has complex coefficients. So that is our second strategy. If we can find some complex root of a polynomial over R, then we know that the complex conjugate of that root is also a root. So that is our second strategy. Our third strategy is to look for useful term grouping. So look for useful, well, not for, look for useful term grouping. And this is a little bit vague, so let's give an example for what we mean by this. So for example, if f of x is equal to x to the 4 plus x to the 3 plus x squared plus x, we see here that there's a pattern here repeating. If we factor out an x cubed here, what are we left with? X plus 1. And if we factor out an x here, we also get an x plus 1, and now we can factor out the x plus 1. So let's factor that out. That becomes x plus 1, x cubed plus x, and again we can factor out another x. So let's put that at the front, x plus 1 and x squared plus 1. So here we have done a whole bunch of factoring, and we see here immediately 0 is a root and minus 1 is a root, and we are left with this factor. So, but we have at least determined 2 of the roots of our polynomial, 0 and minus 1. And now finally, our next strategy will deal with factors that look like this. You could perhaps already see what the roots are here. So maybe let's write that down. What are the roots here? The roots here are, of course, plus and minus I. But this factor has a special form, and that brings us to our fourth strategy. If fx has a factor of the form g of x with g of x equal to x to the n minus c, then of course what will be the factors of g? Those are all the nth roots of c. Then, and there are n of them, then the nth roots of c are roots of our polynomial fx. So if somewhere, if we can write our fx as something multiplied with something of the form xn minus c, we can handle factors that look like this. We can factorize them as the nth roots of c. So if w0 etc. up to wn minus 1 are the nth roots of c, then, and you can do the exercise, then the following x to the power n minus c we can factorize as x minus w0, x minus w1, etc. x minus wn minus 1. Okay, so those are the strategies that we can use to find the roots of polynomials over the complex numbers. And in the next couple of videos we will look at some examples. I will see you in the next one.